This is a review for the Edgenuity lesson, Reciprocal Trig Functions. So just as a reminder, the three functions that we've talked about so far are sine, cosine, and tangent. And the way we write out our ratios is sine is opposite over hypotenuse, cosine of your angle is adjacent over hypotenuse, and tangent of your angle is opposite over adjacent. And I told you of the acronym SOHCAHTOA, which can help you to remember these ratios. So the reciprocal trig functions, the reciprocal of sine is called cosecant. And so all we do is this fraction over here that was opposite over hypotenuse, we just flip it, and now it's hypotenuse over opposite. The reciprocal of cosine is secant. So again, we just flip this, and it becomes hypotenuse over adjacent. And the reciprocal of tangent is cotangent. And when we flip that, it becomes adjacent over opposite. So for example 1, it says, what is secant for angle A? So angle A here is our reference angle. So I'm just going to write out what each length is, what each side is. So opposite your right angle, that's always your hypotenuse. The one that's all the way across from A, that's your opposite. And then your other leg that's touching A, that's your adjacent. So now, secant. Secant is the reciprocal of cosine. So I'm just going to write that out really quick. So if we were finding cosine, that's the CAH, so it'd be adjacent over hypotenuse. But we want secant. So we're going to flip that and do hypotenuse over adjacent. So the secant of angle A, the hypotenuse is 14. The adjacent is 10, and let's go ahead and simplify that. If I divide the top and bottom by 2, I end up with 7/5 for the secant of A. So in the next part of the video, they talked about simplifying trig functions. So these are the formulas that you're going to need to use to help you out. To be fully simplified, there should only be one word left. So it should just simplify to like just cosine or just secant. And it also can simplify to 1. So for cosecant, secant, cotangent, tangent, and cotangent, you can rewrite all of those using sines and cosines so that you can get things to cancel out. So cosecant is the same as 1 over sine, secant's 1 over cosine, cotangent is 1 over tangent, or you sine over sine, and tangent is the same thing as sine over cosine. So if you don't have these written down, I would probably pause the video for a minute and write them down. Okay, so for example 2, we're going to simplify. We have cosecant theta times sine theta. So we need things to cancel out. So what I'm going to do is I'm going to rewrite cosecant basically in terms of sine. So I'm going to use this formula here. Cosecant is the same thing as 1 over sine. So now if I multiply these, remember when you multiply, you just go straight across. So 1 times sine theta is just sine theta. And then in the denominator, if I put this over 1, sine theta times 1 is sine theta. Sine theta over sine theta simplifies to 1. Okay, the second one is got a little bit more going on. So let's go ahead and rewrite the things we can in terms of sine and cosine. So I'm going to leave this sine alone, but I'm going to change the secant. And secant is the same thing as 1 over cosine. And then in the denominator, I'll leave the cosine alone. But tangent, remember, we're going to change it to things with sines and cosines. So I'm going to change that, use this formula here that says that tangent is sine over cosine. So on the numerator and denominator, if I go straight across here, we'd have sine theta over cosine theta in the numerator. And in the denominator, we have cosine theta times sine theta over cosine theta. So here on the denominator fraction here, if we have cosine over cosine, that cancels. So now what we really have, I'm going to move it up here, is sine theta over cosine theta in the numerator, and then just sine theta in the denominator. Now remember, you can't have a fraction in a fraction. So instead of dividing by sine theta, I'm going to go ahead and multiply by the reciprocal. So remember, whatever's in the numerator, you leave that alone. So I'm going to leave sine theta over cosine theta the way it is, but I'm going to multiply by the reciprocal. The reciprocal of just sine theta is 1 over sine theta. So go straight across when we multiply fractions. 1 times sine theta is just sine theta, and then the denominator will have cosine theta sine theta. When you have sine on top and bottom like that, they cancel. If everything in the numerator cancels out, it's just a 1. You have a 1 up top. So we have 1 over cosine theta, and we're not done until it's just one thing. So as a reminder, 1 over cosine theta is the same thing as secant theta. Okay, so now we're going to work on finding exact values for different degree and radian measures. So Edgenuity finds the trig ratios differently than we do at school. So I'm going to show you how we do it at school. And what we focus on are 45, 45, 90 triangles and 30, 60, 90 triangles. So when you have a 45, 45, 90 triangle, the way the side lengths work, opposite the 45, we write in that they're both 1 and that the hypotenuse is the square root of 2. So opposite the 45 degrees, you'll write a 1 in those triangles. Opposite the right angle is root 2. If you end up with a 30, 60, 90 triangle, the hypotenuse is 2. Opposite 30 degrees is 1, and opposite 60 degrees is root 3. So again, those values are 1, root 3, and 2. 2 is always the hypotenuse. So for example 1 here, well, I guess this is like example 3. It says find sine, cosine, and tangent for, and then they give you a degree measure. So if I, like this one here is 30 degrees, so I need to find sine, cosine, and tangent of 30 degrees. So if I were to draw that angle in standard position, it would be 30 degrees. What you always want to do is you want to take this terminal side of your angle and always connect it back to the x-axis. You always go to the x. So now what we have here is a 30, 60, 90 triangle. Opposite 30 degrees, just like what I have right here, I'm going to put a 1. The hypotenuse is always 2. And then this angle then would be the 60 degree angle, so opposite it would be root 3. So this is our reference angle here, this 30 degrees. So this is going to be our opposite, our hypotenuse, and our adjacent. As a reminder, SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, you cannot leave a square root in the denominator of a fraction, so we do what's called rationalizing the denominator. So if you have a radical down there, you just multiply the top and bottom of your fraction by what it is. So it was root 3, so I multiplied by root 3 over root 3. 1 times root 3 is root 3. Root 3 times root 3 is 3. And you can double check that in your calculator. Make sure you're in degree mode. If you do sine of 30 degrees, you get half. Okay, so now let's do it for 45 degrees. So if I draw my angle in standard position, 45, this is 90, so we're halfway to 90 there. Always drop the terminal side back down to the x-axis. So now we have a 45, 45, 90 triangle. So as a reminder, the legs are both 1, and the hypotenuse is the square root of 2. Sine is opposite over hypotenuse. We'll worry about that in a minute. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So 1 over 1 just simplifies to 1. To rationalize these denominators, we have a root 2 in the bottom, so we're just going to multiply by root 2 over root 2. So 1 times root 2 is root 2. Root 2 times itself is just 2. Do the same thing here, and we'll get the same answer, root 2 over 2. Okay, so now let's do 60 degrees. So 60 degrees about there. always drop back down to the x-axis to make a right triangle. Again, we have a 30, 60, 90 triangle, so opposite 60 degrees, that's where we put the root 3. And if you don't have these triangles written down, I'd probably pause the video and copy that down. The hypotenuse on these are always 2, and then opposite the 30-degree angle would be 1. Okay, so this is our reference angle. So we have our opposite, our hypotenuse, and our adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, which simplifies to just root 3. Okay, so now let's talk about what happens if they ask you to find the sine of 3 pi over 4, if they do it in radians. So just as a heads up, if your fraction in radians is over 4, that means you're moving around the graph in 45-degree increments. And the numerator will tell you how many 45-degree increments you need. So this one, I need 3 45 increments. If you're dividing by 6, those are 30-degree increments. So this means I need 7 30-degree increments. And if you're dividing by 3, you're moving in 60 degrees. So this would be 5 60 degrees. As a review, when I talked about radian measure in a previous video, as a reminder, all the way around the circle is 2 pi. And so the way I think of it is actual literal pies. So you bake 2 pies, you shove one up here into the positive part of the coordinate plane, the positive y values, and then you take your other pie and you shove it down here. So it goes half of a pie, a whole pie, that's pi over 2, 1 pie, a whole pie. Then down here we have 3 pi over 2, which is like 1.5 pies, and then 2 pies. So on this one here, we're just graphing, just so that we can identify where we're at on the graph. So we want 3 pi over 4. So if you think about it, that's just the fraction 3/4. So is 3/4 more than 1 or less than 1? It's less than 1. So I know it's going to be on this part of our coordinate plane, because to get over here, that's 1 whole pi, and we only have 3/4 of a pi. So if I split up my coordinate plane here into fourths, so we have 1, 2, 3 fourths there. We want 3 of those fourths. So I'm going to go past 1, 2, and I'm going to hit 3 here. And that right there would be 3 pi over 4. Now let's look at 7 pi over 6. So we want 7 6. So is that more than 1 or less than 1? It's more than 1. So we know that we're going to be down here on this part of our coordinate plane, because all the way to here is 1, and we want 1/6 more than that. So I know I have enough to get all the way here back to the negative x-axis there, because we have 1. Now we want 1/6 more. So if I break this up into 6 pie slices, 1, 2, 3, 4, 5, 6, we want 1, this 1 whole here, and then 1/6 more, just one of those 6. And that would be where 7 pi over 6 is. The last one, 5 pi over 3. So if we look at the fraction 5/3, that's 1 2/3. So I have enough to get all the way here to pi, or 180 degrees, because we have 1. Now we need 2/3 from down here. So if I split this up into thirds, so here's 1. This whole part is 2. Some people get messed up with 270 degrees, but if I'm breaking into thirds, it's 1, 2, 3. So we want 2/3 more. So from here, I'm going to go through the second slice there. And this would be 5 pi over 3. Okay, so now we're going to practice finding the exact values of each of these trig functions. So first one, sine 60 degrees. We already did that on the other page, but I'm going to go ahead and show you again. So draw the angle in standard position. Excuse me. So 60 degrees is about there. Always connect back down to the x-axis. So we make a 30, 60, 90 triangle. Opposite 60 is root 3. The hypotenuse is 2. And opposite 30 degrees is 1. So sine is, I'll write this at the top, SOHCAHTOA. Sine is the opposite over the hypotenuse. So for 60 degrees, the opposite is root 3. And the hypotenuse is 2. So sine of 60 degrees is root 3 over 2. Okay, so for this second one, we're doing something different. We're going to go negative 60 degrees. So all that means is instead of opening up, we're going to open down. So I'm going to go down 60 degrees like this. Okay, so again, we have a 30, 60, 90 triangle here because our reference angles are always positive. So even though I went down 60, the reference angle there is a positive 60 degrees. So opposite 60 degrees is root 3. Hypotenuse is 2. And opposite 30 degrees is 1. Now, you have to pay attention to what quadrant your triangle is in. So if we imagine that this was a real coordinate plane, over here, moving to the right one, that would be positive. But here we're going down 3, and all the values down here for y values are negative. So you need to write that as a negative root 3. The hypotenuse, no matter where you're at, is always positive. So you just have to be careful when you're going left, it would be a negative value, and whenever you're going down, it's a negative value. So cosine is adjacent over hypotenuse. So cosine is adjacent 1 over hypotenuse 2. So cosine still ended up being positive in that quadrant. Okay, so next we're going to do tangent 5 pi over 6. So we want 5/6 of that pi. Okay, 5/6. And I know I'm moving in 30-degree increments because there's a 6 on the denominator. So 1, 2, 3 pieces of pie, 4, 5, 6. So I split it into 1, 2, 3, 4, 5, 6. This time I am using the y-axis. So we want 5 of those 6 pieces. So I'm going to go 1, 2, 3, 4, 5. That's 5 pi over 6. Connect always back to the x-axis. Again, we're moving in increments of 30 degrees. So I know that this here had to be a 30-degree piece of pie because there was only one left. So opposite 30 degrees is 1. The hypotenuse is 2. And then opposite where 60 degrees would be, that's root 3. Now, one of these needs to be negative. See if you can figure out which one it is. This one. Because it's on the left side. Moving left is negative, but then our y value is up. It's going positive 1, so that stays positive. Tangent is opposite over adjacent. So I'm going to go opposite 1 over adjacent negative root 3. And then I'm going to rationalize that denominator by multiplying by root 3 over root 3. So we end up with negative, because the denominator was negative, root 3 over 3 for tangent. Next, we're going to do sine 2 pi over 3. So since there's a 3 in the denominator, I know I'm moving in 60-degree increments. 60-degree increments. And it's 2/3. So we're not even going to make it to the bottom side of the y-axis because we only want 2/3 of a pi. So this one, if I break it up into 3 slices, remember when you're moving in thirds, the y-axis is not a divider. It's 1, this whole thing is 2, and then 3 over here. So if I move 2/3 of that, I only want 2 of the 3 slices. This is 2 pi over 3. Connect it back down to the x-axis. Like I said, you're moving in 60-degree increments. So 60, 20, 60, 120, 180. So this had to be 60 degrees. Opposite 60 is the square root of 3. The hypotenuse is 2. And then the adjacent opposite 30 degrees is 1. Since we moved left, it's negative. And we want sine. Sine is opposite over hypotenuse. Opposite over hypotenuse.